Hey class, if you take a look at page 817, we are going to get started with chapter 13. Our focus is going to be area in general. If you look at the specific topics that we will be dealing with beginning in 13.1, just basic geometric figures, and then as we go through chapter 13, taking a look at the area and perimeter of rectangles and squares, parallelograms and triangles, trapezoids, rhombuses and kites, and then we'll finish off with the area of regular polygons. If you take a look at page 819, you can see that there are a ton of key terms in 13.1. What I do want you to realize though is that these are probably terms that you have heard before. We may do a couple of vocabulary assignments throughout chapter 13, but I do want you to refer to Quizlet every now and again in order to make sure that you're keeping up with the vocabulary, because it is important to know. Down at the bottom of page 819 it says, when you sketch a geometric figure, you create the figure without the use of tools. When you draw a geometric figure, you create the figure with the use of tools. A drawing is more accurate than a sketch. Any tools can be used, such as rulers, straight edges, compasses, protractors, etc. Just want to make sure that you understand the difference between sketching and drawing, because they are going to talk a lot about that in 13.1 for today, so make sure that you know the difference between the two. On the top of page 820, problem 1 starts us off with triangles today. It says, producing pictures, sketches, diagrams, and drawings of figures is a very important part of geometry. Many tools can be used to create geometric figures. Some tools, such as a ruler or a protractor, are classified as measuring tools. A protractor can be used to approximate the measure of an angle. A compass is a tool used to create arcs and circles. A straight edge is a ruler with no numbers. It is important to know when to use each tool. So again, these are the three tools that we may have a chance to use over the course of chapter 13 to create some geometric figures. Bullet points. When you sketch a geometric figure, you are creating that figure without the use of tools. When you draw a geometric figure, you are creating that figure with the use of tools like the ones that were just listed above. And very important here, a drawing is generally more accurate than a sketch. So if you are asked to draw something, make sure you grab a tool. If you have to sketch something, you're just doing it freehand. When you construct a geometric figure, the figure is created using only a compass and a straight edge. You have already worked with basic geometric figures such as points, lines, rays, planes, line segments, and angles. These basic figures can be used to build more complex geometric figures. A triangle is the simplest closed three-sided geometric figure. So what I would like you to do to get started today, for number 1, it just says sketch 3 different triangles. So again, you're just drawing freehand, don't have to use any tools. Then answer number 2, how many line segments, angles, and vertices are needed to form a triangle? So here are 3 sketches that I came up with for 3 different triangles. Obviously yours might look a little different. Number 2, how many line segments, angles, and vertices are needed to form a triangle? You're going to need 3 of each. If we just focus on triangle ABC that I drew up in number 1, you have 1, 2, 3 line segments, segment AB, BC, and AC. If you take a look at the angles, you have angle A, you have angle B, you have angle C, and then as far as the vertices go, vertice, vertice, and vertice. So you have 3 of each in order to form a triangle. Down at the bottom of 820, a triangle is named using 3 capital letters. Very important that you understand it's capital letters representing the vertices listed in a clockwise or counterclockwise order. Triangle RAD can be written using symbols such as a little small triangle in front of it and then the 3 letters RAD. This is read as triangle RAD, pretty rad for that triangle. The triangle shown could also be named ADR or DRA. Again, it just has to go in a clockwise or counterclockwise order. The root word tri means 3, so triangle literally means 3 angles. A triangle is a closed figure because it has a well-defined interior and exterior. Again, some things that you may have heard before as far as triangles go, but remember it's very important to understand the why and the breakdown of why we do what we do and why things are named what they are, in this case the geometric figures that we'll see moving forward. Take a look at the top of page 821 and go ahead and answer number 3 and number 4 from the triangle that was created for you back on page 820. If you take a look at the top of page 821 and number 3, I just drew the triangle that I had on the previous page, ABC, for number 3. The arrows point to each of the 3 vertices in that triangle, and there are 3 ways that I can name that triangle: triangle ABC, triangle BCA, and triangle CAB. Remember, you have to have that little triangle symbol before it, and all of the letters have to be capital. As far as number 4, the triangle that they sketched for you on the bottom of page 820, the sides of that triangle could be line segment AD, segment AR, or line segment RD, and those letters could also be flipped around if you had DA, RA, or DR. Notice that I have the symbol above those letters indicating that it is a line segment. That's also very important, and those letters are also capitalized. As far as the angles in that triangle, there are of course 3 angles. We can name them different ways. Angle A can also be named angle DAR or angle RAD. Angle D could also be named angle ADR or angle RDA. And finally, angle R could also be named angle ARD and angle DRA. What I'm hoping that you notice, which is very, very important, is that in this case you can see that the first angle that I have listed is that middle letter in the other 2, and that's going to indicate the vertex of the angle. Let's talk about on page 821 how we classify or name triangles. It says triangles are classified by their side lengths or by their angle measures. The root word equi means equal, and the root word lateral means side. An equilateral triangle is a triangle with all sides congruent. If you take a look at the bottom, it says an isosceles triangle is a triangle with at least 2 congruent sides. Now what I would like you to do for number 5 and 6, notice that it says draw an equilateral triangle. Label the drawing and include measurements that verify it is an equilateral triangle. And for number 6, you're drawing an isosceles triangle. So label the drawing and include measurements that verify it as an isosceles triangle. So make sure you have one of your tools because you're drawing. Here's an example of what my triangles look like. Obviously I just sketched mine. I have an equilateral triangle that has all sides 4 centimeters, and my isosceles 2 sides are 6 centimeters and the base is 4 centimeters. If you turn to page 822, go ahead and do 7, 8, and 9, talking about scalene triangles and equiangular triangles. Here's a sketch of a scalene triangle that I drew. A scalene triangle has no congruent sides. An equiangular triangle is a triangle with all angles that are congruent. So you can see in triangle ABC, each angle measure is 60 degrees. If you take a look at number 9, how are equilateral and equiangular triangles related? They're really one and the same. Equilateral triangles are also equiangular, and equiangular triangles are also equilateral. If your side lengths are going to be the same, then your angle measures are going to be the same. So that's how they're related. Let's take a look at a couple of ways that we can now name or classify triangles according to their angles. Go ahead and answer number 10, number 11, and number 12. 11 and 12 jump up to the top of page 823. An acute triangle is a triangle that has three angles that each measure less than 90 degrees. So the triangle that I sketched looks very similar to the one that you saw in the previous question. All three angles are less than 90 degrees. They're 60 degrees each, so this would be classified as well as an acute triangle. If you take a look at the top of page 823, a right triangle is a triangle that has exactly one right angle. And a number 12, an obtuse triangle is a triangle that has an angle measure that is greater than 90 degrees, and I have both of those indicated with a circle. With a right triangle, about 99.9% of the time you're going to see that little box in the corner indicating that it measures 90 degrees. If we take a look at the bottom of page 823, now we are shifting our focus to four-sided geometric figures in quadrilaterals, and that is indeed what a quadrilateral is, a closed four-sided geometric figure. Opposite sides of a quadrilateral are sides that do not share a common endpoint. Consecutive sides of a quadrilateral are sides that do share a common endpoint. So go ahead and do number 1 and number 2 at the bottom of page 823. Sketch 3 different quadrilaterals. Again, you don't need tools for this one. And how many line segments, angles, and vertices are needed to form a quadrilateral. Here are 3 of my sketches for the 3 different quadrilaterals. If you take a look at number 2, and hopefully you saw this as you were sketching them, you are going to have 4 of each. Line segments, angles, and vertices. Here would be your line segment 1, 2, 3, and 4. If you take a look at your vertices again, 1, 2, 3, and 4. And if you take a look again at your angles, 1, 2, 3, and 4. At the top of page 824 it says a quadrilateral is named using 4 capital letters. So very important, 4 capital letters that are going to represent the vertices. Again, they're listed in a clockwise or a counterclockwise order. The quadrilateral shown could be named quadrilateral ABCD, quadrilateral ADCB, quadrilateral BCDA, and so on. What I want you to notice is that there's no symbol like there was for the triangle. You just write out the word quadrilateral. Go ahead and answer number 3, 4, 5, and 6 on page 824. If you take a look at number 3, quadrilateral CDAB, quadrilateral DABC, and quadrilateral DCBA are 3 other names that you could give that quadrilateral. 2 pairs of opposite sides in quadrilateral ABCD. You could have line segment AD is opposite of BC and AB is opposite of DC. Remember, those are sides that do not share a common endpoint. If you take a look at number 5, now we're looking at 4 pairs of consecutive sides for quadrilateral ABCD. AB is consecutive to BC, CD and DA are consecutive, BC and CD and then last DA and AB. Remember, these are sides that do share a common endpoint. For number 6, the 4 sides would be AB, BC, CD, and DA, and the angles, the 4 angles that you see in quadrilateral ABCD, angles A, B, C, and D, just named for those 4 vertices. Take a look at number 7, refer back to the quadrilaterals that you sketched in question 1, and then name each quadrilateral. I just picked one that I chose, and I would name it quadrilateral ABCD. We're going to do the same thing with quadrilaterals that we did with triangles. Now it's going to be your turn to draw some different quadrilaterals. What I want you to do is focus on the characteristics of each. So go ahead and at the top of page 825, I want you to do number 8 all the way to number 14 on page 826. I'm not going to do any of the drawing, just really focus on the definitions of these quadrilaterals. We should know these, but just to make sure we reinforce it, a square is a quadrilateral with all sides congruent and all angles congruent. A rectangle has opposite sides that are congruent and all angles congruent. A rhombus is a quadrilateral with all sides congruent. The plural form of rhombus is rhombi. I have also heard rhombuses as well. A parallelogram is a quadrilateral with both pairs of opposite sides that are parallel. A kite is a quadrilateral with 2 pairs of consecutive congruent sides with opposite sides that are not congruent. A trapezoid is a quadrilateral with exactly 1 pair of parallel sides. And finally, for number 14, an isosceles trapezoid is a trapezoid whose non-parallel sides are congruent. So as you look back and as you ended up drawing each of these different quadrilaterals, hopefully you understand the why of how you constructed them. If you take a look at the bottom of page 826, now we shift our focus in problem 3 to polygons. Again, some terms that you are probably very familiar with, but we'll just do some sketching in this problem and we'll finish up with 13.1. It says that triangles and quadrilaterals are examples of geometric figures with many sides. The root word poly means many and the root word gon means side. A polygon is a closed figure that is formed by joining 3 or more line segments at their endpoints. A regular polygon is a polygon with all sides congruent and all angles congruent, and an irregular polygon is a polygon that is not regular. It's not going to have congruent sides or congruent angles. Polygons are named using capital letters representing the vertices, and again, it's listed in a clockwise or counterclockwise order. At the top of page 827, it says the root word penta means 5, so pentagon literally means 5 sides. A pentagon is a 5-sided polygon. They want you to sketch the pentagon and then label the vertices and name it. This is what you are doing for the rest of problem 3. So I'll let you do this by yourself. Go ahead and answer questions 1 through 6 onto the bottom of page 828. That's going to be it for 13.1. Please let me know if you have any questions. A lot of this dealt with basic geometric figures, so hopefully this isn't anything very new to you. But let me know if you do have any questions. Thanks.